Hello everyone, welcome back to my channel. My name is Nnamdi. My name is Nnamdi. I'm from OBINexus Computing team. Today I want to introduce something called a new tool called LibPolyCall. LibPolyCall is a library that's polymorphic that makes polymorphic calls, also known as a polymorphic call library. The problem is that the problem it solves is using API development to seamlessly integrate all API systems into one unified system. The problem for work, the problem that the book addresses it shows the problem is this polymorphic call or polymorphic functions and all the data across different languages. Take for example, a function with a type string, a simple function add two numbers a and b. They're type numbers, but now you want to have string support. You have to assert different logic. Um, you have to assert different logic. So you now have a function a and b that has two numbers. You have these two numbers are type of integers. You then assert that logic, and now you want to add a number to a string. That's the name of polymorphic. Like it's polymorphic in nature. Like you assert different type of data. Polymorphic nature. LibPolyCall is LibPolyCall LibPolyCall is a polymorphic library that for any language. It's language agnostic. It's data agnostic. It doesn't care. It just gives that data. It's just a huge milestone in developing APIs. I'll show you how it works. But about a word about LibPolyCall on the store. When you go to page.com/OBINexus, you can search for LibPolyCall. LibPolyCall can get an individual license, uh, business license, and an enterprise level partnership and insights on the project. So that's for projects. Individual license is just one license. You just get a user documentation. You get documentation to get everything to it, and you get the business license. You get documentation and support. So you can message me directly and then to make polymorphic calls and see how I can tell out for your business. And then you get a partnership program where you can partner with us and pitch ideas and help you. If you're just really good, you have to get approval. If you're a business, you want to get approval. This approval, you work with me. We'll give you insights on the on our tools or more tools that may be useful for you. Um, more data too, so it can help you understand how to go about your own business processes. LibPolyCall is a polymorphic call library. This is C program. Okay, so traditional APIs fall short of or fall short because every API. Say you have a weather API, and the weather API traditional weather APIs have rigid compilations. So if I want to say I have a weather API, a weather API, uh, a weather API, then want to make a call to it in Python or Node.js or Scala or even C. I have to have a C implementation to drive that logic. I have to import the weather API package or for C or Python for Node. Know that. And it's very old true driver code to just drive the logic. And API is very bad. Have a trouble API design because I have to learn the language associated with the bindings, with the package itself, which are called bindings. Now I'm going to tell you how LibPolyCall solves all this problem, all the mess of architecture. What LibPolyCall does, all LibPolyCall does is very simple, but it's very beautiful as well. LibPolyCall.polycall.exe is the main entry point for the program. Now, LibPolyCall has something called a config file. That config file just the binding architecture. Let me give an example or an analogy. All squares are rectangles. All squares are rectangles. Not all rectangles are squares. Simple. That's a very simple analogy. So this is what LibPolyCall uses as an example. So all squares are rectangles, not all rectangles are squares. This means that all bindings to data, any function that transforms data and binds to data are squares in that aspect. They are packages, node packages. they don't drive logic. They just bind to data and bind to logic. That is the binding of that's called the binding, the Node.js binding or Python Polyglot binding or any binding like that. And there is something and as a Python, a lower binding, C binding, C Polyglot, Node Polyglot. These bindings are what the developers install to go into their Polyglot exe file, which is making the project. Now, all bindings are bindings to the Polyglot, which ships the data, which exports the data, what the server calls to handle the data. That's your server calls the bindings. That's fine. And all drivers are all drivers. There's no driver. The server is a driver code, so the server handles the logic of the user, controls the user, how the user interacts with the server. That's the important bindings to drive the second architecture. So even for Node Polyglot, we have a mutation of Node Polyglot, and that Polyglot binding. That's Polyglot for using the server. Now, when the end user wants to come to an API, so the server, this is a server architecture model. So that's what LibPolyCall is. What LibPolyCall is a program, the exe program. It's meant to handle the server request. What LibPolyCall really does, what the Polyglot exe is doing is really it's a proxy. It's a proxy and a reverse proxy program that handles the data and gives it to the client. So let me give you an example. It's an intermediary. What it is an intermediary proxy system that handles the data between the server using the Polyglot binding and the main client who wants to consume that data. In traditional model, it's very hard to set up a system like that because Polyglot is it's one of the tools. It's really one of those tools that's really make sure that that's really better than solving problems because it's sort of binding from driver code to actually execute logic. But the bindings are just mapping to data. But you can still drive bindings, you can still drive logic too. Just remember that too. So I'll show you how to use the Polyglot. So let me give you an example. So the server architecture model is like this. You have a server on the internet anywhere in the world. The first command you want to give you have first anywhere in the world, and it's a proxy system. So when a user make a request to the server, which changes the data, the Polyglot intercepts the data, intercepts the service request, and then intercepts between requests, and then handles the data processing. The Polyglot exe handles the data processing, and then gives it back to the server. Puts it to the server, gives it to the server, and that server stores it with all its data. Now, if the same user for that data session whatever, and that user can then request that data again and get that data back. The problem with the protocol so far is it's really program interface. It's really a program. So anyone can request any data off the server, and the Polyglot will just give the data. It doesn't matter. So we have to have authentication commands where authentication authorizes command to make sure the users are authenticated authorized what they are. So Polyglot is a proxy system and a reverse proxy. It's a bouncer at a nightclub. It lets people in. That means a reverse proxy. A proxy is someone that intercepts a request of an agent and processes the research. So what Polyglot is a bouncer and a proxy system too. So that's what the Polyglot is. It keeps a program configuration files that are secured. So what I'm now introduce the features of Polyglot. Polyglot is a Polymorphic library. So you have a standard binding system to bind to any language, but you can write your own Python package, anything. If you have a different requirement in your security, your bank, there's COBOL systems. You have to write your own COBOL bindings to that system and then import it to your financial bank application to then use it. Now, you can use that in a secure binding way, or you can use anything like that. Now, if you have your Node.js binding, you can use Node.js in anyone, Open Polyglot, Node Polyglot. The main objective of Polyglot is Polyglot is the center of all communication. You're gonna handle data in language list condition, and he doesn't care. Just give the data and has a request get post. Remember, update delete, so CRUD operations. Both of them with the standard HTTP request. It is stateless and it just serves that data for any binding architecture. Now, I want to choose a command. So you have the first command I want to introduce is the FFI. So for any language you use, you have the FFI command. You have Python FFI, Node FFI, which is quite natively with the bindings. I want to make it called the Polymorphic library. Although I'm going to show you the trial. Again, I'm going to introduce the command so far. So you got the Polyglot configuration file. To configure the files on the Polyglot system, where the Polyglot file is what it is. So you have a configure Polyglot file, and when you configure data, that's what it is. So what we're seeing now is you have the binding, the FFI command, which is for function interface interaction, which is seamless communication within for Python binding, Python the header, HFI binding, in Python, and you got the FFI command. So the Polyglot FFI to handle function interfaces, allow, you know what I'm saying, for systems you don't need separate configuration. You got the micro command for microservices. Microservices are everywhere now. So you could do micro command is have a bank card component next to a ad service. You then want to go to the bank card, and then say you don't know whether third party ad services are malicious, so it's just to take the security risks. You don't want to get security either. So therefore you just isolate the micro command, the Polyglot micro command does is isolate the bank service from ad services, and that's what the Polyglot micro command does. So you can isolate components, bank card, and that data, isolation data, ship an API and isolated data in the real world, in the real environment. Now, how Polyglot really works is in the real environment, you do the Polyglot file, configure the Polyglot, and that sets up the whole system for you. You can configure you add the bindings, you add the node bindings, which is just package, node bindings, which is sort of node packages. Node Polyglot packages or Polyglot, any Polyglot system you're using to interact with the main system. And the ship user the data based on anything you want to do. And that's binding. Then you got FFI command, you got the core binding logic. Now you got the macro command for FFI config and micro. And now you could be trying to make it, we're working on the new commands. You got the edge computing command. The edge computing command is very important. It's for node caching and trigger updates only when needed. Often this is an update. Say you have a server in United States and you have one in UK and you have someone in let's say France, and then you don't have a server. Oh no, you have a server in US, let's say America, and you have a server in UK. And the root server is in the US. Let's assume that. And then you have a new server here, but you don't have one in France. You don't have one in France. How the podcast starts? So it's also the edge computing command, edge source, the edge computing problem where we want one problem to bring Alexa, stop. Where you want to bring data closer to the source of data. So get computer to get people edge computing is very important to get people their data, get people information, get people where they are, information as soon as possible. So how this problem is solved is we cache at the nearest node on the server. So if there's a cache, so if the US server is in the US server there, and then UK server, yes. And now the data is sent from the US server to the UK server because it was requested from the France server. But the France server caches at the server where it's going to be get back. Unless an update is triggered on the database and the people using the Polyglot API and usually United States of America, then the Polyglot system will update the system. So the France will then make a request to the server, to the UK server. We then look for updates on in the US server to then deploy the updates. But if there's no update, it's all cached and the server architecture just works. That's the Polyglot edge command, edge computing command, edge command. And there's one more. Wait, so we got the telemetry command. Telemetry command is very important. because we all have a Telecom is very important for this gathering, insight gathering. So you have a survey, any survey on programming languages, you want to learn best, you want to know people use your site a lot, and you want to know what languages you use for tutorial. You want to get insights, any data. Of any data, telemetry can help you gather insights on the data, why people use servers and everything. Telemetry means gathering. Telemetry just means gathering data, insights, and information reporting. That's what telemetry really gives you. So that's the Polyglot telemetry command. Although I'm going to show you the trial version, this command has to be implemented in the full version, and it works with the Polyglot RC file, which can be in JSON or the Polyglot standard file. So that's what it is. For the binary architecture, you don't have to mix and match. And don't forget to know, you have to now so that's a command that's implemented, can be implemented, but I'm going to show the core binding command, how to use the Polyglot in a real world environment, and try to show you how to use it. How to use it now. Okay. I'm going to show you how to set this up and use it. Okay. 1 second. Oh, okay. Thank you for watching, and like, share, and subscribe. Okay.